And greetings, everyone. I'm Paloma from India, and I will present my work on measuring rural inequality in India with a multidimensional approach, which was completed under the supervision of Professor Daniel Cassese, University of Cambridge, as a part of the one-on-one mentorship program conducted by the CCIR. So India, as we're all aware, is a fast developing nation. However, the development is not consistent for all levels of the society. And though we generally relate this inequality to poverty, previous research by Agnes Deaton shows that individual income doesn't have much to do with the inequalities in other human developmental variables, which perhaps depend on factors other than income. And this brings us to the need to calculate the inequality by a multidimensional approach, the inequality in all the other spheres of development to be able to correct it. And thus our research objective, to calculate rural inequality with a multidimensional approach. So moving on to our data source, collecting primary data being next to impossible given the COVID scenario, we chose a bit older data which was publicly available, that is the most recent government census conducted in 2011. Now we had a lot of variables to deal with, say health, education, the types of jobs that people did, the hours of electric power available, the housing facilities, the types of roads, crops grown in every area, and of course the income earning households. And we had to choose the variables such that we only overlook negligible information and yet get a data size that is easier to deal with. So we considered the prime aspects of each variable and ignored the rest. So for instance, good health would depend on a proper sewage system, cleanliness, and so forth. However, if we consider a clean environment and good sanitation, that would not indicate the availability of doctors or quality drinking water, which are the primary influences for good health. Similarly, the number of households with a regular salary would give us an idea of the income with a greater precision, rather than having information about the kind of jobs that people did to earn that income. So we kept these things in mind, and we ended up having 4 major variables, which we plan to calculate in greater detail. So first, we have education. The data for education contained information regarding the number of institutions for each branch or stream, which was subgrouped as under public and private education. So under the assumption that every level of education from pre-primary to professional courses is equally required, we aggregated them by assuring that each segment of education gets equal weights, and hence we got 2 results: the total number of public and private institutions respectively. We then divide both these results by the respective population of the village to get an idea of the per capita index of education for, again, both public and private institutions. And finally, we obtain a single measure for education. We calculate the geometric mean of the 2 results obtained above. And we may also like to note that the reason that we choose geometric mean for the aggregations is we would like to focus and give greater weight to the least performing districts in terms of the rank. And now we come to a second variable, that is health. So we first need to understand the segregations between the healthcare institutions. Now, a public subcenter or a PSC caters for approximately 3,000 to 5,000 people, but more than the treatment, it serves as a preventive and informative center, like hardly qualifying for a hospital. Thus, we would ignore these in our calculations. This, along with the private healthcare, because of the varied range of treatments that is included in it. For example, private healthcare has a major constituent called the tantrics or the faith healers. Now, these medications are not scientifically proven, so we decide to not keep them in our calculation, and we concentrate primarily on the public healthcare centers and the community healthcare centers, which cater for 20,000 to 80,000 people respectively. Now, what we do with this data is we primarily consider the total deficit of healthcare by subtracting the actual number of hospitals from the desirable number of hospitals. And how do we find out the desirable number? We have the total population of the district and we divide it by the threshold number that a particular hospital must serve or cater to. And again, we find the two variables, again, that is PHC's deficit and CHC's deficit. And we find the geometric means of these variables obtained for the very same reason as in education. And with that, we complete education and health. And we come to the question of water availability. Now, the following calculations are relatively way simpler. We simply find the number of taps available per person, followed by our last variable, that is income, where we do something similar. We get a fraction of the income earning households by dividing the latter by the total number of households. And we then combine all these four variables to obtain a multivariate matrix. This is the final matrix that we are going to deal with. And lastly, we calculate the multidimensional Gini index upon this matrix given by the formula, though we would come back to this later in our discussion. And now we would look at particular results in detail. So for education, we obtain this table citing the highest and the lowest values. Now, Tripura has a shocking 0 in both cases, which we kind of attribute to its geography, along with the fact that the northeastern states have been secluded from the mainland politically too. Now, to prove our inference that the geography of the place is indeed a factor of the inequality experienced, we plot a graph against the two variables. So we have the distance of the institutions from the main city, and we have the Gini index of inequality, obviously. And we see that the graph results in a predominantly downward slope, in fact, proving and yet it being the highest, it has a very, very low number of 0.002. And now the question is, why so? Now, this can be attributed to the capitalistic motive of the private sector in general. So the farther the schools are built from the city, lesser number of students from obviously poorer backgrounds would attend the schools, meaning a loss for the private administration. And it clarifies a possible explanation for the ignorance of the private sector to build schools in rural India altogether. Only the ones built in the past remain. And finally, we plot a heat map using Python based on the variable, and we observe a huge spectrum of colors from which we infer that educational inequality is fairly high in rural India, suggesting a large gap between the rich and the poor. Now, in terms of health, we obtain a similar table like the one in the education. And while equality in the southern states and West Bengal may be a factor of the leftist governance, whereas the high deficits in UP and Bihar may be a consequence of long tribal belts for primarily two reasons. One, they are horrifically exploited, and two, they don't welcome the allopathic healthcare provided by the government institutions in many cases. However, in the heat map here, inequality visually appears to be lower than that in education, since the color range is not as broad. Although that isn't a good sign given the 50% of health poverty stricken population as compared to the 10% of educational poverty. But however, now we move on to water availability. And since a household typically consists of 5 to 6 members, let's consider each house to have one tap, which must be sufficient if there is constant water supply. Now, the ideal measure of the availability of per capita tap water in that case should be 1 by 5, that is 0.2. But any value above 0.2 should be considered rich in terms of tap water availability. But unfortunately here, our data shows a number far lesser than 0.2. As we can see, the highest value is 0.006. And this measure in our data frame was presumably not a good choice. Though tap water availability gives us an important measure of potable drinking water, the result confirms that there are alternatives to the latter, such as boiled water obtained from wells or rivers, etc. Thus, the availability of tap water should not be considered as an ultimate measure of availability of clean drinking water, since it can be a potential source of error in this case. And finally, we use inequality in income to compare it with the inequality in other variables. Now, visually, we can't see any correlation, but what we do find mathematically is education and health are way more correlated on each other than them being correlated on income. Right? If we really speak with the values, we can see that health is related to income with a correlation of minus 0.02, and education is correlated on income with a correlation of minus 0.01. However, we can see that the correlation between health and education is the highest, that is minus 0.008. Now, that kind of confirms what we had actually guessed visually. Lastly, we look at the results of the prime calculation of our work. Now, these two formulae given here are taken from the Degenk and Lugo paper 2009, which I referred during my research. And now these mainly differ in two senses. One, the order of summation across individuals and dimensions, and two, the distribution of weights. Now, if we concentrate on the order of summation, we observe that in the first method, we first aggregate across the individuals and then across the dimensions, like in Human Development Index or the HDI. However, in the second method, we aggregate first across dimensions and then across individuals, maintaining a correlation among dimensions. And in the original paper, it is concluded that the second is a better method to approach multidimensional data mathematically. So obviously, in this paper, we too go with the second method. Here, beta is the measure of how egalitarian our function would be. So theoretically, for beta equal to infinity, we could get a perfect complement in the society where we assume the society earns no welfare if the poorest person does not earn any. However, here we consider beta equal to 1, that is perfect substitution, that is everyone is given the same importance, basically for the ease of calculation. And we take delta to be 1, 2, 5, and 100 to understand how our evaluation of welfare changes when it is utilitarian measure, then when delta equal to 1, when it is increasing the bottom sensitivity, when delta is becoming 2, 5, and finally when it is heading towards a Rorschach measure when delta equal to 100. So finally, we consider the weight factor, that is W, to be 0.25, again giving equal weights to all the dimensions. And calculating upon our data set, we obtain these numbers. So we have the Gini index to be 0.006 when delta equal to 1. And this gives us a clear idea about the kind of inequality that exists in rural India. Now, when every district, whether rich or poor, was given equal weight, we encountered this horrifyingly low value of 0.006. But when we started increasing the bottom sensitivity, we ended up having a greater value of the Gini index, and increasing by even 1 digit increased the Gini index by 0.5, implying giving a bit more weight to the poorer districts magnifies the social welfare by a huge, huge amount. And this is something that I think we should really focus on, and which has already been done in the previous cases in order to eradicate the inequality. And to sum up, I would state the major findings of the work. So first, we provide a mathematical proof to Deaton's prediction in his 2001 paper, which I mentioned in the introduction itself, that we find that the effects of income, that is health and education, are least dependent on income. Instead, they are dependent greatly on each other with a comparatively higher correlation. And in terms of individual results, the public sector outperforms the private sector in terms of equality in the educational facilities of rural India. Health has a lower inequality, but obviously greater poverty when compared to education, while tap water availability performs the worst throughout, and we have already kind of seen the reason. Some states do better than others, obviously due to the advantages of terrain, natural resource availability, and other geographical factors, and socio-political and historical factors also decide these results greatly. And in my opinion, changes in government level policies, which should basically include bridging geographical barriers, socially eliminating the communal and the caste hierarchy, which is pretty dominant in India, and instead of actually propagating them, which we kind of see these days, and also controlling the extent of the capitalistic motives. These could be a few very direct solutions to the most evident reasons of inequality that we measured. So thank you, everyone. And for any questions, you're welcome.
Thank you so much, Paloma, for that awesome presentation. You obviously really went in depth and dove deep into this topic. I'd like to open the floor up to anyone who might have a question on this presentation.
Thanks a lot for the presentation. It was definitely interesting, and as said, it was very well researched and clearly presented. A couple of questions from my side. The first one is about the multidimensional matrix approach. I assume that you gathered 4 different variables, right? Is there any idea of making it more complex or taking into account more factors? And do you think it'll be more interesting to take into more accounts? Because I see the concept of correlating them becoming very interesting on your results. So do you have some other factors in mind which you want to take into account in the future studies?
Yes, well, definitely. That's a very insightful question. Well, I should say that the more data that we include in our research, the more we increase our data size and statistics, the more definite results we head towards. So I think if we include like the other variables that I initially mentioned that we would not consider for some reasons, but if we can refine the variables such that we can actually include them, then I think, yes, it would be a really, it would broaden up our precision. So I think, yes, if that answers your question.
Thanks. The second one was an interesting note I made about the correlation factors. If I got it right, the result was the correlation between education and health. These 2 variables of the matrix was higher than education to income or health to income, which doesn't sound like very trivial for me. I would assume the other way. Am I getting anything wrong, or was it an interesting finding for you as well?
Well, I should say that I was surprised too when I initially got it. I was really confused. I checked my results twice to actually see it, but then I talked to my professor, and what he said is that is the main crux of the matter in the Dayton's 2001 paper. And what we really want to focus is that if we talk individually, if I say that if I have more money, obviously I will get better health. But imagine a situation when you have a lot of money, but you are living in a village where there is no healthcare facility. Would that make any difference to what kind of healthcare you will achieve? No. So that is the thing. So healthcare and education, these do not depend on individual income. These depend on the kind of society that a person is living in. So that is the reason that they are more correlated than they are correlated with income. So similarly for education, because these are supposedly social functions that happen. So it should include a society for it to happen. So it will in no way depend on what is your income or in which rank you stand in the income, because if there is good healthcare being provided, then irrespective of your income, you would get a certain level of healthcare in general. So I think, yes, that's it.
Yeah, that's the answer I was looking for. Yeah, that clears up a lot, but it's not very trivial, right? Definitely, I think general audience would go for the other way.
It is something to be really, yes, it is to be really thought about.
Yeah. But do you think still, I guess from your answer, the distance from the healthcare and the government's progress in the healthcare system, a lot of stuffs matter. But still, I have one small doubt on this correlation between education and health, which showed up higher. Do you think the numerical number you showed, 0.008, is a good correlation factor, or is it comparatively better than education, health, and the other versus health? Or we just get, because of the three numbers, it seems too much, or is it like we are missing any factors? I think you got my question. Yeah.
Okay. Yes. So the thing is that if I remember correctly, I did mention the word comparatively, and if I didn't, I'm really sorry, because no, it is not a very, very good measure of correlation, because it is still a negative value. So it is still negatively correlated. But yet, if we compare between health and income, or education and income, they are, way lesser. But I think that this is where the factor of poverty comes in. How greater this correlation would go would depend on how the overall income in the society is higher. So if we are in a wealthier society, then I think that this value should go up. But this is of course something that we could work upon later.
It's also seemed to again to me. I'm just wondering about the fact that it seems to be a basic question, but then how one can miss a lot of factors, and how can it affect the overall result? Yeah, thanks for the results. One last question would be on the Gini coefficient you are using. I remember using it in some of my things personally, but I guess there are some inherent limitation of that. It doesn't go well along with some data sets properties. Like, will it take into consideration of the actual structural changes within the data set, or how it changes along with the data set's population? I remember there are some couple of limitations on it on bigger data sets. How do you tackle this?
Yes, so that I would say is the limitation of my research too, because here I'm completely depending on the Gini index. So if I remember correctly, in some of the research papers that I read before, they had compared 3 different methods of multidimensional aggregation. Gini index was, like, multidimensional Gini index was not one of them, but still they mentioned that between those 3 results, the ones which could compile the data first across dimensions and then across individuals, so that would give a greater, a more precise result than the other methods. So I think, given the available literature that I had, and given the discussion with my professor, I think I went with that. But of course, if it would be good to explore the other mathematical instruments which would actually reduce the chances of error. So yeah.
Great. That sounds like a good idea. But I would definitely appreciate your. I guess Gini index, it's a well-establishing, and it's been used in a lot of population data set analysis and stuff. So it's not that you tried something trivial. It's one of well-established. But if there is any possibility of improving and refining your results, it would be even better. But thanks again, and that was very interesting results. Good luck. Yeah.
I just want to add one thing, that the Gini index that is generally used is actually the Gini index of 2 dimensions. What we did here is the multidimensional Gini index. So that, has certain higher, I would say, positive side than the 2-dimensional Gini index, because as we increase the number of dimensions, again, as we said, that we go towards more preciseness. So that was indeed a reason that we used multidimensional matrix, so that we can incorporate as much as data, and we get a more precise result. So yeah, I think more work.
Right way.
Yeah.
Yeah, clearly you are on the right way, because I can see you have saw the possibilities, and I have already seen that you have noted this issues with sensitivity, or a couple of stuffs you can play with and refine the results, right? The couple of slides on sensitivities and other factors. Yeah, good luck. Yeah, we'll be looking for it for your future results. Yeah.
Thank you. Thank you.